When presenting the findings of a study, people often don't show the original data that were measured, but they present so-called derived data. Derived data can be percentages, rates, ratios, indices, and other types of data. For example, considering a dataset of smoking behavior, percentages could be used to describe a dataset of smokers and non-smokers. Here the percentage is derived data. While this may be an intuitive way to present results, it should be noted that when only showing percentages or other derived data, there is a loss of information. If you only see percentages, then we don't know how reliable the data is, because 20% could either mean that 1 out of 5 individuals was a smoker, or it could mean that 1,000 out of a sample of 5,000 individuals were smokers, which would be a much more reliable sample. Hence, when showing derived data, it is always good to present at least the sample size. Another issue with derived data is that data type changes. For example, using percentages means that we have transformed non-metric data, the number of smokers and non-smokers, the attribute smoking, into metric data. Now we don't have counts of attributes anymore, but we have metric data. This also means that we have to choose different statistical tests because those for non-metric data are not suitable anymore. So what is the best way to use derived variables and to present data? For presenting data, using derived variables is fine. For statistical testing, however, original data should always be preferred. If you use derived data, then there is a chance that you don't detect differences which you would have detected if you had used original data. A completely transparent presentation of a statistical test results showing also derived data could be, in a small sample of patients, 10 women, 10 men, there were more smokers in men, 30%, than in women, 20%. However, this difference was not statistically significant. Fisher's exact test, p equals to 1.0. With this information, you have everything you need to understand how meaningful this difference is. Why do we use Fisher's exact test? Well, if we look into the flowchart for test selection, here in the software GSS, we have two groups, women and men. Data is not paired. Pairing would be that you measure, for example, before and after treatment in the same patients. We have no information on data distribution, hence we choose non-normal data to be on the safe side. Our data type is nominal data. We measure the attribute smoking. These data are not metric, and there is no ranking order in the groups. And finally, we have counts smaller than 5, and hence Fisher's exact test is the appropriate choice. Finally, there are further drawbacks when using derived data. One is that we do not only lose information if we show only derived variables, for example, information on the sample size, but we also lose accuracy. A value of, for example, 1.2 may be any value between 1.15 to 1.25. If instead we show counts, then we always have accurate values. Another issue is that the distribution type changes. Derived variables are often not normally distributed, even if the original data are normally distributed. This can easily be seen when considering percentages. Percentages can only range from 0% to 100%, or from 0 to 1 if you consider a fraction. Such data cannot be described with a normal distribution, which extends from minus infinite to plus infinite. Also, a log normal distribution would not be suitable, since this extends from above 0 to plus infinite. The only distribution which can describe percentages is a beta distribution, which is limited to the values between 0% and 100%, or 0 and 1 if you consider a fraction. However, you will have difficulties finding a test designed to work with a beta distribution. The only option may be to use a test for which no assumptions regarding data distribution is made. In conclusion, derived data are useful for presenting results, since, for example, a percentage provides an easy-to-understand summary of the data. However, for statistical analysis or testing, original data should be used. And when you use derived variables, it's always good to provide additional information such as sample size.